All right, here we go.
Hello.
Moving on with Unit 5. I've got a special guest here. I've got Mr. Zerkowski with us today.
How are you doing?
Super excited to be here.
I couldn't be more thrilled, Mr. Cryan.
Math videos are awesome, right?
I'm so excited.
So here's what we're doing today. We've already learned what inverse functions are. We've graphed exponential functions. So logically, the next step
Let's graph a logarithmic function under a series of transformations.
Transformations. Always fun. So let's get to it here. So first thing we need to talk about is what the heck is actually a log, right? Or a logarithm. So I've got a sentence here. It says, in the exponential equation, 2 to the third equals 8. 3 is the exponent to which 2 must be raised in order to obtain 8. Makes sense, right? 2 cubed is 8.
So far, so
Yeah,
good.
okay.
So far, so good.
We're good with numbers, so it makes sense. It's all good there. So now we'll throw in kind of the vocabulary here. So that 3, that exponent, instead of just calling it an exponent, we're actually going to give it a name, logarithm. So we call 3 the logarithm to the base 2 of 8. Sounds like a handful. It is. It's kind of confusing, but we can abbreviate that. So we can take this exponential equation and we can turn it into what's called a logarithm. So 2 to the third power equals 8 can be rewritten as a logarithm like so. This is abbreviated 3 equals log base 2 of 8. That's how you read that, log base 2 of 8. So I'm going to put the definition right here, which we'll read through in a second. But the big thing here, and it's bolded, is that whenever you hear logarithm, you want to think or know that a logarithm is an exponent. As you see, the 3 is our exponent in the exponential form. The log equals the exponent in log form. So let's just read through the definition here. A log is an exponent, and log base a of x is the exponent to which a must be raised in order to obtain x. So the number a is called the base, x is called the argument, and that's important when we're graphing, right, of the expression log base a of x. Okay, we're always going to deal with x, or your of part, that's always positive. And to relate this back to exponential and inverses, which we've done, so here I've got an inverse equation, here I've got a log equation. They are inverses of each other. So the exponential work we've been doing, now moving into logs, if you think about inverses, it's really going to be the same as graphing exponential form, just as its inverse, right? So we had to define that stuff. You with me, Mr. Z?
So far, I just want to make sure I've got this straight.
Okay.
So I can write an exponential function as a logarithm, like into equivalent forms. But because I'm switching the x and y in the inverse, the exponential is the inverse of a log.
That's exactly right.
Okay.
So let me put it this way. Going back to our inverse discussion on domain and range. If I had the domain and range for my exponential, moving to my log, it would be
reversed or
there you
flipped.
go, right? The domain of your exponentials, the range of your log, and vice versa, right? So let's try to graph that stuff.
Okay.
So if you were with our exponential video, this would look very similar there. So here was our basic log form, log base a of x. Now we're going to restrict a, our base, to any number greater than 1. Okay, same as we did with our exponential function. So a couple things to realize here. First of all, again, the log is the inverse of exponential form. So a couple key attributes here we want to talk about. The function's always going to be increasing, so when a is greater than 1, when your base is greater than 1, your function's always going to be increasing and continuous over the entire domain. The y-axis is a vertical asymptote. Now, in exponential, we were used to having our horizontal one, right, over the x-axis. But since it's the inverse, it kind of makes sense that we no longer have a horizontal, we have
A vertical.
a vertical, yeah. So we're going to have one straight down the y-axis there. If we were to write that equation, it would be what, Mr. Z?
Y equals 0, or x equals 0 instead of y equals 0.
That's correct, yeah. Okay, so the third part, the graph passes through those points. Those look familiar. If you watch the exponential video, which you watched it, right, Mr. Z?
I do.
You watched your videos.
Riveted.
Oh,
yes.
geez, yes. Remember, for exponential form, we had 3 key points, right?
Correct.
What do you notice when we compare here?
Well, that's right. Inverse functions, you just switch the x and the y values.
Oh. So, do we have to learn 3 brand new points for this?
No,
We just flip the old one.
that's
Oh,
right.
Oh my god, this is so easy. So, here's our 3 essential points. Here's our first example. I want to graph f of x equals log base 3 of x. So we'll set up our table, right? Now, if this was an exponential function like we've done before, I would do -1, 0, 1, and then 1, right? And then I deal with my base. But log is the inverse of that, right? So it's going to be -1, 0, 1, and then that 1 there. That's, again, coming from this. So again, a is your base, right? A is whatever your base is, and that's your inverse of your base. So here we go. In this function, it looks like 3 is my base, right? So what would be the inverse or reciprocal of that?
1/3.
1/3, right. And then my base is 3, so 3 there. So those are my 3 parent points that I'm going to have to graph. So what is that going to look like? 1/3 -1, right there. 1, 0, and 3, 1. There we go. See how it's always going to be increasing and continuous there?
I do.
Okay. So it's just like graphing exponential, except it's the reverse of those parent points. Very simple. Just like exponentials again, what about a base that's in between 0 and 1? Fractions, Mr. Z, fractions.
Oh, I couldn't handle that.
Man, like the worst part of high school is probably fractions.
I agree.
It's not like
The nightmares and
finding a
therapy.
prom date. It's not, the ACT. It's not even like final exams, right?
No.
Driver's license,
Mm-mm.
all those major miles. No, it's fractions, right?
Yeah, adding, subtracting fractions is a nightmare. But we're not doing that here.
Oh, we're not really. Yeah, we don't really have to deal with that. So anyway, so your base is going to be in between 0 and 1. How does that change things? Notice now it's going to be decreasing over the domain. Do our points change because our base is now a fraction?
No.
No, it's the same step. So here we go. Notice on this one, your base is now 1/2, right? Probably set up our table. It's always good to have a table. -1, 0, 1, 1 there, right?
Correct.
So if my base is 1/2, the inverse of that would be, Mr. Z,
2.
oh, and then my base goes here, right?
Correct.
Again, A inverse and A. So where's that asymptote?
I think it's still at y equals 0.
Oh, x equals 0?
Yeah. Every time.
X equals 0, yes. So, let's graph our points, huh? So 2, -1, 2, -1. Oop, hey, a little off there. 2, -1 is there, and then 0 or 1, 0, and 1/2, 1. Always decreasing, right?
Correct.
Okay. Now, if we go back to our learning target, Mr. Z,
Okay.
what was on the back half of that learning target? We had to graph these under
Transformations.
transformations.
Ooh.
Like Transformers.
Oh, I
Like-
like Transformers.
Like there's more than meets the eye, or is it robots in disguise? I never got that. It was one of those two sayings. I don't know. Maybe we'll Google it later. So, here we go. Again, I've got the 3 points there. You always want to start with your essential points. And what are those essential points again? A inverse, so what's that?
-1.
-1, right? And then,
1, 0.
oh, yep.
And then A1.
Got it.
Oh,
A1.
shit.
A1, just like the steak
Oh,
sauce,
I like
right?
the steak sauce.
Just like the steak sauce.
Yeah.
Let me move these bad boys down here a little bit. All right. So, table. Start with our essential points. So, what's my base in this one, Mr. Z?
2.
It's a 2. Very
Yeah.
good. A is going to be 2 here, right? So, let's throw in our essential points. Good. So, my x-coordinate for the -1 would be?
1/2.
All right. And my x-coordinate for the 1 would be?
2.
All right. Sweet. Now, am I ready to graph?
No.
No, I've got some more stuff. Remember, if I have, you write this over here in a different color. I got different colors down here. I don't have to write in red the whole time.
That's
Yeah.
awesome.
If I've got my general log equation here, remember, anything that happens to the x, argument, is there an E in that?
Yes.
Argument, like
Oh,
that?
no.
No, that's right,
After
yeah.
the-
I mean,
I didn't know
You didn't know there
which
would be
E.
a spelling check in this video, did you?
There is an E. I didn't know you were asking me if there were two E's. Yes.
So-
one E.
Yes. So that's your argument. So anything that changes in here is going to affect your x values, right?
Right, so that's a horizontal shift, right?
Yes. Very good. Very good. So I need to change up my table here. I got to change my x values, right? So this graph, now if there's a minus in the argument, that actually shifts it to the
Right.
right. So I actually want to add 1 to all my x's, correct?
Correct.
Okay, great. Now, there's that tricky thing, that asymptote that's in there, right?
Right.
Normally it's where? Where is it normally?
X equals 0.
At x equals 0. So let me draw a line here. Is that where it's going to go?
No, because it has a horizontal shift of right 1.
Yeah, so if I move my graph to the right 1, that is now going to be shifted and be at x equal to 1, right?
Oh, that makes so much sense.
It does, doesn't it? So let's get our points down. Basically going to add everything, or add 1 to all my x's. My y's will stay the same. No vertical shifts or changes there. So 1/2 fractions.
Okay.
What's 1/2 plus 1, Mr. Z?
1.5 or 3/2.
Yeah.
We'll
Yeah,
leave
we'll
it
go with
1.5.
1.5, yeah.
That's fair enough.
1 plus 1?
Is 2?
Great. How about 2 plus 1?
Ooh, 3.
Yes, that's a tough one. Once we get past 3, those are huge numbers. So let's graph now. Carefully graph this, kind of going backwards the table here. 1.5, -1. 1.5, -1. Boom. 2, 0. Boom. And 3, 1. Boom.
It looks kind of like the normal function just shifted to the right one.
It exactly is, right. It exactly is. Very good. You want to do this next one, Mr. Z?
I would be honored.
Oh, the privilege is all mine.
Oh, I'm going to use blue.
Oh, that's a good choice.
My cubby blue.
All right. Oh boy, let's not go there.
Maybe by the time they hear this video years from now, they'll have won. All right, so you're going to start with your t-chart. The base, in this case, is 1/3. So if you think about the parent function, the asymptote used to be at x equals 0.
Right.
With the base of 1/3, that means that you start with the 3 key points. So the inverse of 1/3 is 3 and 1/3 1.
Oh, I like it.
So that would be my parent function of this log. So, but now I look at my transformations.
Oh, there's a lot of stuff going on there.
It is 2 things. The x plus 2, oh yeah, that's with the x, that's my horizontal shift of, not a plus 2, goes the opposite way, that is left 2.
Oh yeah, the opposite.
Yeah.
In the argument's the opposite.
And then this -4, oh, that's the vertical shift, and that is on -4. That is down 4.
Outside, what you see is what you get, right?
Correct.
That's right.
Yeah. So when I make my new t-chart, the x values are going left 2. So instead of a 3, when I -2, that is now going to be a 1.
Very good.
And the x value of 1, when I -2, it's going to be a -1. And 1/3, when I -2,
Oh.
this is
Oh,
mind
man.
blowing. This is going to be
Good luck,
negative
Mr. Z.
1 and 2/3.
That's why I gave you this problem.
Ah, yes. Now the y values are going down 4.
Yeah.
So that y -4, so -1 -4, it's now at -5. 0 -4 is now at -4. 1 -4 is now at -3.
I like it. That's very good.
So now,
Sorry.
oh, that's all right.
Do your magic.
This vertical asymptote now, instead of being at x equals 0, because it was a shift left 2, it is now going to be at x equals -2.
Yes.
So, that vertical asymptote is now at x equals -2. Now that I have that in place, now all that is left is to plot the points on my graph. So 1, -5. There. -1, -4. And -1 2/3.
You gotta be very precise.
-3.
Yeah.
Mr. Crane will pull out a ruler, mark it wrong if it's off by even a fraction.
Was that a fraction joke?
Kind of.
Your fraction off by a fraction?
Uh-huh. All right.
That looks awesome, I gotta say.
Well, that's why you brought me in.
That looks great. I know, right? I mean, look at that. I mean, look at that. Look at this guy. I mean, look at this graph right there. Isn't that crazy?
And it keeps going in either direction.
Right? Either direction. So,
Yeah.
let's review really quick. We just found out that the log, right? The log is the inverse of exponential form.
Yeah,
Right?
that's right, that's right.
So we can basically, remember, the log is always an exponent, right? The log equals your exponent of your exponential form, right?
Right.
So basically we take our exponential parent points and flip them around,
Yeah.
right? Domain and range switch.
Yeah, that's
So-
what inverses do.
We got our 3 key points here, A inverse -1, 1, 0, A and 1. So we use those to graph, apply any transformations we may see. We just had a bunch of shifts in these problems, which
Yeah.
we've been doing since Unit 2, Mr. C.
They're masters by now.
They should be. So, so hopefully now you guys are able to graph log functions under a transformation. Thank you, Mr. Z. We couldn't have done it
My
without you.
It's my pleasure,
Yes.
Mr. Crane.
All right, we'll see ya.
All right, take care.